So today I am starting polynomials. The polynomials, as you have come across in 9th class also, you are familiar with this. What was that? Polynomial is any algebraic expression where the power of the variable cannot be fraction or negative. That means the power of the variable has to be whole number. Then only that algebraic expression can be called as a polynomial. So a general expression for a polynomial, when writing, say p of, and we give the name of a polynomial like this, p of x. That is, p is the name of the polynomial, and x in the bracket is, the variable associated in the expression. So the general expression a n x to the power n plus a n minus 1 x to the power n minus 1 plus a n minus 2 x to the power n minus 2, etc. In this way it will go like this: say a2 x square plus a1 x plus a0. That means when that is the powers of the variable are n and it is in the descending order, the powers are in the descending order I have shown, and it is ending at x to the 0. That is when the power of the last term x to the power 0, and this is 1. So the last term is a constant. So okay. Now you see, with each term there is a coefficient associated. When this coefficient has to be real number, and depending upon the value of the real number it will be decided whether this term will be there or not. That is, if the value of the coefficient is 0, then this term will not be there. That means if a to the power n minus 1 is 0, then this term will not be there. So in this way, if that is a0 is 0, then there will be no constant term. So that means the value of the coefficients, which are real number, will decide what terms will be there in the polynomial. Okay, but that is the general one I have shown you. Okay, now so the main important in this n, that is this n, has to be whole number. It cannot be fraction or negative. That you have to. These are the characteristics of a polynomial. Okay. Now, two important thing about polynomial, is degree. One is degree, and the other is the number of terms in the polynomial. Number of terms in the polynomial. So this degree is, and also another thing I should say, the value of the polynomial. This thing you should know. And also I think, so the first thing, degree, that that is the highest power of the variable. So if this n is going down in the descending order, so obviously here n is the degree of the polynomial px. N is the degree of the polynomial px. Since n is the highest here, so the highest part of the variable in the polynomial is known as the degree of the polynomial. Okay, and how many terms will be there, that will be depend upon the value of the coefficients, real coefficients. And the value the value we get by putting some particular value of x in the polynomial. For example, suppose let me take some specific polynomial. Say p of x is equal to, say 2x square minus 3. I am taking a simple polynomial. Degree is 2 and the number of term is 2, so it is binomial. So how do you get the value? That is, for different value of this variable, that is, if I take the value of x to be 1, that is x is equal to 1, then in the place of x I put 1. So 2 minus 3 is minus 1. Similarly, how I get the values. If I take 2, if the value of x is 2, then it is 2 into 2 square minus 3. 8 minus 3, 5. So in this way we can get the value of a polynomial. Okay. Now let me write it in this way. So this is the general polynomial, general expression of a polynomial, x to the power n plus 1. Okay. So polynomial in terms of degree, if I define, say, degree, and also I can define in terms number of terms. So you see, degree, if the degree is 1, we say linear. If degree 2, it is quadratic. It is known as quadratic polynomial. If degree is 3, it is cubic. If degree is 4, biquadratic, etc. So in this way we can define. So in terms of degree we can define a polynomial: linear, quadratic, cubic, biquadratic, etc. And similarly in number of terms also I can define in this way. Say, if only one term, then it is monomial. If 2 term, binomial. If 3 term, trinomial, etc. So these names, from these names we can will be able to know how many terms are there, and with these names I will be able to know about the degree of the polynomial. Okay. Now let's okay. So let us first write the general terms of polynomial. General expression, let me write. For linear polynomial, that means it will be in place of a1 ax plus b. Power is 1. So for quadratic, ax square plus bx plus c. For cubic, ax cube plus bx square plus cx plus d. Then for biquadratic, ax to the power 4 plus bx cube plus cx square plus dx plus e, etc. So this is the general convention of writing an polynomial. That means you see the linear degree 1, so you see the coefficient of the highest power will be always a, and in this way the coefficients of the decreasing term goes following the alphabets. Okay, so this is the convention of writing a polynomial of different degrees. Now we'll come about the zeros of the polynomial. Zero of a polynomial. Very important term, zero. Now you know we have if p of x is a polynomial, then say x square minus say 4, polynomial, degree 2, and is a binomial also. So for I have shown you for different values of x I am getting different values of the polynomial. Now for that particular value of x for which the value of the polynomial is 0 is known as the zero of the polynomial. So here you see, actually that will be able to see if I factorize, then I can see the zeros very easily. So you see this can be factorized by the identity a square minus b square is a plus b into a minus b. 4 is 2 square. So from the two factors I can very easily say if any one of the factor is 0, then the value of the polynomial will be 0. So when this factor is 0, what x will be? It will be minus 2. So when this factor is 0, x will be minus 2. And when this factor will be 0, that means x will be 2. So these are the two values of x for which the value of the polynomial px will be 0. Hence we say that minus 2 and 2 are zeros of the polynomial px. So by factorizing a polynomial, we can easily find out the zeros of the polynomial. That is, the value of the polynomial has to be 0 for those values of the variables. That are zeros. So that is concept of 0 is clear. Now in this 10th class, actually here we will be learning the relationship between zeros and the coefficient. That is very important thing we will be learning, and it is very many applications I will be showing you later when solving some difficult questions. Now first of all, 0 is okay. Now next thing, I have to find out how many zeros a polynomial can have. So as we see, corresponding to each factor there will be 0, and the number of factors is equal to the degree of the polynomial. So the maximum number of 0 a polynomial can have will be equal to the degree of the polynomial. Why I am telling maximum number? You see, there can be situations like this. If px is 2x square, let me take a simple one. X square minus 2x plus 1. This is a quadratic polynomial. Now if I factorize, it will be like this: x minus 1 whole square. You know the identity, a square minus 2ab plus b square, so it is a minus b whole square. So that means it has two identical factors. It has two factors, but both the factors are identical, is not it? Actually it is like this only. So from each factor I am getting the zeros which are equal, same. So even the degree is 2, but the number of 0 is 1 only, since they are identical. Then take another example. Let px is equal to x square plus 1. So you see, this cannot be factorized into two factors, not possible, because of this plus sign. If minus, then it is possible, but for plus is not possible. So we see that this x square will be always positive for any value of x. Whether positive or negative, it will be always, square is always positive. So a positive plus 1 will be always positive. So it will be always greater than 0 for all values of x. That means what? This polynomial has no 0. There is no such value of x for which px is 0. So though it is a quadratic polynomial, but it has no 0. So that means a polynomial whose degree is 2 may have no zeros, 1 0 or 2 0. So maximum number of 0 it can have is 2, which is equal to the degree of the polynomial. So from that we can conclude that a polynomial, the number of 0 a polynomial can have is equal to the maximum number of zeros a polynomial can have is equal to its degree. It cannot be more than that. So that one thing we know. Now let us see one more thing, how we can find the zeros from graphs, that we can see. So px is expressed polynomial. Px will be some expression. Say, let me take linear one, x plus 2. I'm taking. So px is actually nothing but y. That is, y is equal to x plus 2. So we can draw graphs. You know. If I plot graphs, when x is 0, y is 2, somewhere here. When x is minus 2, it is 0, 1, 2, so it is like this. So we will be getting a line. We will be getting a line like this. This is your graph of px. So any polynomial can be expressed graphically. And you see, in a line will always cut the x-axis at one point. So this is only one point. And what does it mean? The intersection of the graph with x-axis means y is 0, because any point lying on the x-axis, the y is 0, that is the ordinate of that point is 0. Any point lying on the x-axis, ordinate of that point is 0. So from that I can say, no, y is nothing but the value of the polynomial. So the point of intersection of the line with the x-axis gives you the value of the 0 of that line, which represents the polynomial. So obviously a linear polynomial will be that's why the name linear polynomial, because the graph of this linear polynomial will be always a line, and there is only one point of intersection. So hence this is your point of intersection gives you the value of 0. So here it is minus, at this point x is minus 2, so minus 2 is the 0 of the polynomial. Similarly, if I plot a quadratic polynomial, say px is equal to x square minus 1, then I know the zeros are for x square minus 1 factors are, so when x is 0, y is minus 1, so it will be here. And when x is plus 1, y is 0, it is your 0 minus 1, 1 0 minus 1 0. So if I plot, this is px, x square minus 1. So even suppose this graph is given to you, then you look, these are the 2 points where the graph cuts the x-axis. So these 2 points will be the zeros of the polynomial. So the abscissa of the 2 points is 1 and minus 1. So 1 and minus 1 are the zeros. This 1 and this minus 1 are the zeros of the polynomial is. So 2 zeros. Similarly, if I have a graph like this, where 1, 2, 3, 4 points, so it is px, graph of a polynomial is given like this, then simply looking at the point of intersections with the x-axis, I can locate the zeros of the polynomial. Because at this point y is 0 means the value is 0. So 1, 2, 3, 4. That means this polynomial will have 4 zeros. That means it will be a biquadratic polynomial. Similarly, if there is 3 point of intersection like this, say, x. So if a point is like this, say 1, 2, 3. This is a graph of a polynomial, say px. Then we can tell about the degree of the polynomial, 1, 2, 3. So there will be 3 zeros of the polynomial, since there are 3 points of intersection with the x-axis. So in this way, by looking at the graphs, we can tell about the number of zeros the polynomial has. Okay. So one thing, okay, that's all.